Okay, a binomial distribution. There's going to be several parts to this video. There's no way I can get this done in 15 minutes or 10 minutes. So part one of a binomial distribution is just understanding that bi means two. So we have two ways of doing something. It's either success or failure, yes or no, true or false, left or right, up or down. So you've always got two possibilities. So this fits into Pascal's triangle quite well, and kind of a neat connection. So here, let's say we have this honeycomb, and what Pascal's triangle is a series of numbers. So 1 would be row 0, 1, 1 would be row 1. Then you'd have 1, 2, 1 for row 2, and then 1, 3, 3, 1 for row 4, and so on down the line. And what's happening in Pascal's triangle is we had the two previous to get the next one. And then we'd go 1, 4, 6, 4, 1. And so 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and on down the line. Well, we want to know why that is. And so let's think of this as a bee. Okay, and this is a honeycomb. Kind of looks like a honeycomb. So we've got this bee here, and this is going to be the most pathetic bee you've ever seen. So there's my bee. And he's going to start here at the top. And he can get to any cell in his comb. So he could go down here. But the problem is he has to start at the top, and he can either go left or right only. So left, down and left, or down and right. Okay, those are his only possibilities. So let's look at this one. Let's say he wants to get to 6. Okay, if he wants to get to 6, and he's starting to, I'll erase my B because that's pathetic. If he wants to get here, and he starts here at 1, we're going to do a different color. Okay, he could go left and down, right and down, right and down. So that's left, 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 right, right. And that's one way of getting there. Okay. And let me put that one back in there without the ugly writing. Okay, he could also go right, right, left, left and get there. So there's two paths. Okay. Do blue for another one. So he could go left, right, left, right. He could zigzag down there. And so there's another path. And he could go right, left, right, left. So there's another path for the blues. Let's use reds now. Now it's getting a little tricky. So he could go, so far we have 4. So there's 2 more ways he could get there. And these 2 are a little less obvious. But he could go right, left, left, right. Okay. Or he could go left, right, right, left. And so there's 2 more paths, totaling 6 ways. So there are 6 ways in which he can get to this cell. All right, and that means down here at 36, there are 36 ways to get to this cell. Now, if you wanted to get to this 10 cell right below and right, well, each one of these means that's how many paths going left and down and right and down there are. So you've got 6 here on the left, 4 here on the right. Well, to get to 10, the only way you can get to 10 is either be on this pad or this pad, and that's 6 and 4, which is 10 ways. So you'd add the 2 paths together, and you get 10 total ways. Similarly, if you wanted 35, well, there's 20 ways to get here and 15 ways to get here, and that's the only way you're going to reach 35. So 15 ways here, 20 ways here gives you 35 total. And so that's why that works. Now, so that's the binomial part of it. So it's left or right, true or false, heads or tails. And so let's think about heads or tails for a minute in Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay. Now, let's think about each row as any. So the first row is the 0 row. This is the first row. This is the second row. This is the third row. And this is the fourth row. Okay. If you think of this as a, let's think of it as heads and tails for flipping a coin. Okay. I guess this first row would be that you didn't have a coin. So your number of coins is 0. Heads and tails. So if you had one coin, for this one, you could either have a head or you could have a tail. Okay. For the second row, you could have 2 heads, because now we have 2 coins for the second row. You could have a head or a tail or a head, or you could have 2 tails. Okay, kind of similarly to the B. So we're going head if you go down and left, tail if you go down and right. So going this way one more time means you went left, left, or head, head. Here, there's 2 ways to get to this middle one, either a head, tail, or a tail, head. So head, tail, tail, head. Okay, and working down, now we have 3 coins for the next row. So this would be 3 heads, head, head, head. There's only one way to get 3 heads. Okay, this would mean here you'd have 2 heads and a tail. Well, there's three different versions of that. You could have done a tail, head, head. And I apologize, I'm kind of squeezing them in here. Or you could have also done head, tail, head. So those are the 3 ways in which you get 2 heads and 1 tail. This one here, this 3 here means for 3 coins, that means 2 tails and 1 head. So you'd have head, tail, tail. And you can kind of see that by our little stair-step method with the B. So we could go head, tail, tail, or you could go tail, head, tail. So tail, head, tail. Or you could go tail, tail, head. And so those are all 3 possibilities. And then this last one, there's only one possibility, and that's jumping down with 3 coins to 3 tails to the right. And so that's your entire sample space. So there are 1, 2, 3, 4, 5, 6, 7, 8 total possibilities. Or 3 coins, 2 times 2 times 2 is 8 possibilities. So when you go to the last row, and hopefully you're starting to kind of figure this out and understanding what the connections I'm making here, but this would be then, and I'm not going to do all of these, but this would be 4 coins for the 4th row, and if you did the 5th row, it would be 5 coins. So this would be 4 heads. Head, head, head. Okay, there's only one of those possibilities. And so this would be 4. So let's say, it depends on what you choose now. So let's say my sample space is how many tails we choose. I'm going to do tails because it bothers me to go the other direction. Don't know why. So this would be 0 tails. This one right here. 0 tails. That's the same as saying 4 choosing 0. So we're going to, out of 4 things, we're going to choose 0 tails. Out of 4 flips of a coin, how many possibilities are there with 0 tails? And there's 1. And if you do 4 choose 1 or 0, you will get 1 possibility. For this one, there's 4 paths to get here. If you remember, this would be head, 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 tail. So this is 4 choose 1. We're going to choose 1 tail because I made X tails. And there's 4 of those. I could list them all out, but I think you get the picture. I hope you do. This would be 4 choosing 2 tails. There are 6 ways to choose with 4 coins. There are 6 ways to get 2 tails. You know, you could have head, head, tail, tail. You could have tail, head, and you know, on down the line. You're going to end up with 6 of them. It's a nice way to also check to see if you have everything. This would mean 4 out of 4 coin flips, we're going to choose 3 tails. And then the last one is 4 choose 4. Okay, and that would be 4 choosing 4 tails. What's nice about this is it's symmetric, and if I would have said, and I'll do it in a different color, let's say that x is equal to the number of heads now. Well, you just flip everything. So this is now 4 choosing 4. This would be 4 heads for this first one. This one would be now 4 choosing 3, because it's the same as 4 choose 1. 4 out of 4 coin flips, I'm going to choose 3 heads. This is 4 coin flips, 2 heads. It stays the same. This would be 4 coin flips, 1 head. So this becomes a 1. So 4 choose 1. It's easy to get confused here. And then the last one would be now 4 choosing 0 heads. And they all end up with the same, you know, this is everything that you could deal with the 4th row. And you could do the same with the 5th row, 6th row, 7th row. So that's enough of that. You might, wow, that looks like a mess. You might, I hope this helps somebody. It really did me. When I first seen this connection, I fell in love with binomial probability. Completely changed the way I look at mathematics. But it probably wasn't so earth-shattering for you. Well, good luck on this. There's going to be a couple more parts, because now we're going to start showing you how to actually get to the probability part. That was kind of the binomial part, and how binomial connects to combinations and how to count things. Now we're going to use that counting to figure out the probability of 4 coin flips. What's the probability of getting exactly 2 heads? What's the probability of getting at least 3 heads if I toss 4 coins, and things like that. So that's the next video. Best of luck on this. See you next time.